So today we're going to talk about congruence. Here's what it is. Those two triangles, A, B, C, D, E, F, are congruent to each other. There's a rigid motion that would map the one triangle onto the other, and they would match up perfectly. So the corresponding angles are congruent to each other, and the corresponding sides are congruent to each other. So you can think of congruence as being equal, except we say that there has to be a rigid motion that maps one onto the other. Now, if you take a look, it shows the symbol for congruence right here. So this again just means if I put the two triangles on top of each other, they will match up perfectly. So we're going to look at the side lengths, corresponding angles, and what exactly that means. So up to the top of the sheet, when we say that one figure is congruent to another, it means that there is a rigid motion that maps the first onto the second. So that could be a reflection, a rotation, or a translation. So remember, just always keep in mind, you put the figures on top of each other, they're going to match up perfectly. So the rigid motion maps each part of a figure to a corresponding part of the image, which we'll talk further about in the next question here. In the figure below, the triangle on the top has been mapped to the bottom. So first of all, we want to describe it. Well, because if you look at it, see how this is congruent to this side. That means that however long GF is, HF is the same length. If we measured it with a ruler, they would be the same length. That means they're congruent. Because of this, the only way to get GF on top of HF is to actually do a rotation. So we're going to say the way of a rotation, and it would take that triangle upside down, so it's going to be 180 degrees. And we want to write the center of rotation. What point is it about? So it's going to be about point F right here in the middle. About point F. I'm going to have carpal tunnel after this. Okay, usually I'm just doing constructions in the videos, not actually writing so much. All right, so we want to now identify all 6 pairs of corresponding parts. So this triangle, because there's a rigid motion, a rotation, that means that this triangle is congruent, the top triangle is congruent to the bottom triangle. If we put them on top of each other, everything's going to match up. All the corresponding sides are going to be equal, and all the corresponding angles are going to be equal. But now we can say, basically, the angle, equal, instead of saying equal, we can now say congruent. So let's start with the angles. Okay, so let's take angle G. Well, what angle is G congruent to or equal to? Well, after the rotation, G, rotating it, would map onto H. So angle G is congruent to angle H. And how you would mark that in the diagram? Now, they already have actually single markings for this angle, so we're going to have to do double. So double at G and double at H. Okay. Let's do E next. So angle E, what angle is E congruent to or equal to after the rotation? Well, if you rotate E 180, we're going to land onto I. So E is congruent to I. Whoa. So I'm going to put 3 markings now. So our diagram's going to get a little bit crazy, but that's okay. And the third angle they actually already have marked in here. So angle, let's do the top one first. Angle EFG, angle EFG. Can't use just one letter and call it F, because how do I know if you say F if you're talking about the top one or the bottom one? So angle EFG is congruent to, okay, now we have to do this carefully here, ready? You have to do the rotation after each one. So first letter we wrote was E. Where does E rotate to after 180? It goes to I. Okay. Middle letter was F. Where does F go after the rotation? Well, it's going to still be F. And then where does G go after the rotation? G rotates to H. Okay. Next, we're going to do the sides. Let's do the ones we've already marked. GF, that side. Now, what side is it congruent to? Meaning the same length. Congruence, the same length for sides. Well, GF is congruent to HF. Remember, you have to do the rotation. So if you list G first, you're saying after the rotation, where's G going to go? G is going to H. And then after F is rotated, where's it going? Well, F is just staying. Okay, let's do EG next. Or we'll do EF because they already have the double markings. Okay, so EF with a double marking, EF is congruent to, or the same length as E would rotate to I, so it's going to be IF. So this lesson is really all about the ordering of the letters. Okay, and the last side, we're going to have to do triple marking. So EG on the top, EG. Doesn't matter what order you give for the first one. It's that the second side has to match up the first side. So it's congruent to, okay, well, E will rotate to I, and G, the second letter, would rotate 180 to H. So E, G, and IH are the same length. Okay. Next, just move this down here. Use the properties of rigid motions to explain why triangle EFG is congruent to IFE. Well, how do we know those triangles are congruent? Remember, anytime you have a rigid motion, it means you have congruent figures. So what's the rigid motion here? We want to be specific and just state what rigid motion is it. Well, it was a rotation, right? Well, because it's a rotation, how do we know that those triangles are congruent? Because rotations preserve two things that we've already, okay, it says rotations, it's in there, the I's there. We've already said that, hey, the corresponding angles are congruent, the corresponding sides are congruent. So it's because rotations preserve distance and angle measure. Okay, I can't go any faster. This is going to be like 5 minutes of me writing 3 words. So because rotations preserve distance and angle measure, that makes those, we'll do and like that. Okay, it makes those triangles congruent. Think about it, the length of the sides are the same, the angles are the same. That means the triangles are congruent. There we go. Okay, number 4. Triangle A prime, B prime, C prime is the image of triangle ABC after a sequence of transformations. It's asking if the triangles are congruent, and then we have to use the properties of rigid motions to explain our answer. First, let's see what transformations we see. Okay, I see it as a translation sliding down 3 and then a reflection over the y-axis. So when it's asking are the triangles congruent, hold on a second here. There we go. I've just figured this out now, by the way, that I can type and it'll go a lot faster. Okay, yes, they're congruent because remember, if you have any rigid motion, you're going to have congruent figures. Now, how do we explain that? Well, we want to state the 2 transformations we see. So we'll say translations and reflections preserve distance and angle measure. So if the distance of the side stays the same, the angle measure stays the same, then that means that our 2 triangles are congruent. Okay, let's go down to number 5. All right, the triangles below are congruent with angle ADB congruent to angle CDB. That's actually already marked in there. Angle ABD congruent to CBD, that's marked in. And this one we do have to mark in ourselves, so let's do that. So it says that BD is congruent to BD. How you would mark that in, because it's the same side, both of those triangles share the side, you just put an X over it. Okay, which statement must be true? Basically, what you have to do here is you have to really focus on the ordering of the letters. So I hope you guys can tell that this is a reflection, okay? If I fold one triangle on top of the other one over a line BD, they're going to map onto itself. So remember, it's a reflection. Okay, so choice 1, angle ADB. I'm just going to keep putting like dots in those spots and we can figure it out. Angle ADB here, congruent to angle CBD. That's not true because see how it has a single marking and then has a double? That means those angles are not equal to each other, so that doesn't work. Okay, so let's keep going. Choice 2, angle ABC. Now this whole entire angle, congruent to angle ADC, this whole angle. Well, that wouldn't be true either because this is double markings and these both have single. If I add them together and add them together, they're going to be different angle measures, so that doesn't work. Okay, so let's get rid of that. Okay, next, choice 3, AB is congruent to CD. So AB here, congruent to CD here. Now this doesn't make sense because if we reflect this triangle over BD, AB would not go on top of CD. That doesn't make sense. So the correct answer has to be 4, but let's check it out. This one says AD, congruent to CD. Yes, these sides are the same length. If I fold AD over, it will land on CD. Okay, so there's that one. Okay, next let's do number 6. We're going to do just one more here. Number 6, I'm going to draw a diagram. Let me pause this and see if I can get some nice triangles. Okay, this will be much nicer than if I was going to draw it myself. So it says the triangles are congruent. So when you draw your triangles, you have to make sure they look exactly the same, as if a reflection or rotation or translation happened, rigid motion happened, but they look exactly the same. Now, when you put the letters in, this is important. The first triangle is JKL. That one, it doesn't matter where it goes. So I'll just put J in the corner, K at the top, L in the other corner. This is what matters though. J is the first letter, which means it maps to M, the first letter. So J and M have to be in the same spot. And then the middle letter K maps to the middle letter N. So if K is at the top, I have to put N at the top. And then the last letter L goes with O. So if L is in the bottom right corner, then O is in the bottom right corner. Okay. Now you can get the answer to this question either using the letters on the top here, the triangles, or you could get it by looking at the diagram. So let's just go through both and you can see. So angle KLJ congruent to angle NMO. No, that is not true. They would have to be in the corresponding position and they're obviously in different spots, so that doesn't work. Now let me show you how you can get choice 2 if you don't want to use the diagram, how you can get it using instead the triangles on the top. Okay, so for choice 2, right, angle KJL. So you look at the order. So see how it's K is in the middle, then the first J, and then L. Like it went middle, first, last. It would have to do it over here as well. Well, middle, first, last would be NMO. This does not say NMO. So if you don't have a diagram, you can get it just looking up here at the order of the letters. So let's do choice 3 here. Let's do the order up at the top again. JL, so that'd be the first and third, congruent to MO, first and third. Yep, that matches first, third, so 3 has to be the right answer. And you can get it on the diagram also. JL is the bottom side, congruent to MO, which is also the bottom side. So either way, it is choice 3.